good day, grade 11s and grade 12s, and your favorite uncle is back. All right, so today we are continuing on Euclidean geometry. So if you have not subscribed, make sure you do the right thing. All right, as we jump into this wonderful example, right, let's start. So they say to us in the diagram, we've got PQRS. Okay, sorry about that. We've got PQRS, which is a cyclic quad. All right. So please, as you read this information, it's important that you make mental notes for yourself, or if you want to, you can highlight in one way or the other. Right. So we know that this PQRS is a cyclic quad. Even if they had not told us, remember that the vertices of this quad, all of them touch the circumference of the circle, right? Okay, so let's continue. So now they say to us, PQ such that PQ is equal to PR. So now note, ladies and gents, we also have PQ. Right, so there's PQ equal to PR. So what does this tell us now? That if those two lines are equal, remember what it does is that it makes triangle PQR an isosceles triangle, right? And we know that the base angles of an isosceles triangle are equal. So that means if those lines are equal, then it means those angles are also equal. All right, now let's continue. So they say the tangents of the circle through P and R meet QS produced at A. Right, so there's our tangents there, right? So they are meeting at a common point outside the circle, which is point A, right? And in this case, they're simply saying, they are produced, so which means they form a straight line. Remember, once we say that a line is produced, so it means that it would form a straight line. Okay, so they say RS is produced to meet tangent AP at B. Okay, so there it is. They're telling us that that line RB is a straight line, right? As well as PS, which is produced to meet AR at C. Again, we've got a straight line there, which means PC is a straight line, right? So remember, whenever they tell us about straight lines, guys, we are going to look at either exterior angles of a triangle, we're going to look at exterior angles of a cyclic quad, or it might be even vertically opposite angles, right? Okay, so let's get right into it. Now, they say to us PR and QS intersect at M. All right, now they say giving reasons, prove that S3 is equal to S4. Now, ladies and gents, I'm going to show you, I'm going to show you a method in this case where you solve by actually making one of the angles being to be equal to X, right? So what we're going to do is we're going to identify one angle. So they said to us, we must prove that S3 is equal to S4. So I'm going to do this. Let me start with S4 because it's within that circle. Let's call S4 X. And so what we're going to do, ladies and gents, we're going to try and identify any other angle, right? Before we answer the question, any other angle that is equal to X. All right, let's try and do that. So S4 is equal to X. So which other angle is equal to X? That means that R3 would also be equal to X, isn't it? These are angles at the same segment, but we did say that R3 should be equal to the whole of that angle Q because we've got that isosceles angle, triangle rather. So in this case, that means this is equal to X as well. All right, so if we use our tangents, you'd see how R3 is equal to P4, right? So remember, that's the 10 chord theorem. That's the tangent. That's the chord. the angle opposite that chord. But also you'd see how it means that this whole of angle P1 and P2 would also be equal to x. We'd use the 10 chord theorem. There is the tangent. There's our chord. Angle on the opposite side of the chord is that angle x, angle Q1 and Q2 over there. So this would also be equal to x. All right, so any other angle that is equal to x, ladies and gents, of course, it might look a little bit clumsy and all over the place, but at the end of the day, it really does work wonders, right? Now, what do we also note? Remember that tangents from the same point, right, are also equal. So that means that RA would be equal to PA. So those lines there are also equal. So in this case, what does that mean? It would mean that angle angle R1 and R2 should also be equal to x, isn't it? But why is that? Remember, it is equal to x because of the fact that we can either use 10 chord theorem, right? So there it is, it's equal to Q1 and Q2. Or you can say it actually forms an isosceles triangle, right? So it would form an isosceles triangle PAR, right? So those angles are equal there. I know that it looks horrifying, because of all of those angles that are equal to x. But can you see that S1 would also be equal to x? That's an exterior angle of a triangle, isn't it? Okay. And I want to please, exterior angle of a cyclic quad in that case. All right. Actually, it's vertically opposite angles with S4. And what do we note? R3 would also be equal to x. Now, why is that? It's an exterior angle of this cyclic quad. Remember, exterior angle of a cyclic quad is equal to the opposite interior angle. So it is equal to that angle there. And of course, S6 would be equal to x as well. So do you see that we've proven that S3 is actually equal to S4, right? So here's what I want us to do, ladies and gents. Let's do this. Let's write it down. Okay? So where did we start? We said let angle S4 equal x, right? So then what we did was to find another angle that was equal to x. So we said S4, angle S4 is equal to angle R3. You remember that? So we said S4 is equal to R3, which are angles at the same segment. R3. Okay, these are angles at same segment. Okay, and then so this is equal to x, right? And then we said R3, right? Because PR is equal to PQ given. So PQ is equal to PR. Okay, so PQ and PR are equal. This was given to us. And so therefore, triangle PQR is isosceles, right? That's an isosceles triangle, right? So in this case, it means that R3 would therefore be equal to angle RQP, or you can say Q1 and Q2, right? So Q1 plus 2 would be equal to angle R3. And why is that? Angles opposite equal sides. Or you can say the base angles of an isosceles triangle, right? So that is also equal to x over there, right? And then what did we note? Now that we've got that angle to be equal to x, right? So remember, how did we now get to S3? So S3 will now be equal to that Q1 and Q2, Q1 plus 2, right, which is equal to x. And why was that? It's an exterior angle of a cyclic quad. Okay, so please note, we've got an exterior angle of a cyclic quad in that case, and as a result, because it is an exterior angle, it will also be equal to x. So that is how we got S3 to be equal to S4. Now I want to take you through it again, ladies and gents, right, without all of these disturbing diagrams or images, right? So where did we start? We started at S4. We said S4 is equal to R3, angles at same segment, but because RP, right, was equal to QP, okay, all right, so RP is equal to QP. So in this case, it made those angles equal, isn't it? All right, now note in this case, because that angle is also equal to x, we noted that the exterior S3 is the exterior angle to that cyclic quad, that whole cyclic quad there. I want you guys to please note it. Okay, so that would be an exterior angle to that cyclic quad equal to the opposite interior angles, and that is how we got S3 to be equal to S4. Okay, right, now let's continue, guys. So they said to us, now SMRC, we need to prove that SMRC is a cyclic quad. Now let's go there. SMRC, so SMR, okay, right, let's try and get it to look nice. Okay, so SMRC, okay, this line is misbehaving. Okay, so R and C, so this must be a cyclic quad. So note, the reason why we need to prove it is because it is not within the circle, isn't it? Okay, so we need to show at least one of the properties of a cyclic quad in order for us to conclude that it is a cyclic quad. Now, what have we done? We've already proven that S3 is equal to S4. Now, would you agree with me that S1 is equal to S4 as well, right? That is a vertically opposite angle to S4, right? And then I want you to also note, ladies and gents, that this angle here would also be equal to x. Okay, so that angle would be equal to x. Now, two ways in which you can do it: either by using the 10 chord theorem, so R1 and 2 would actually be equals to Q1 and Q2 using the 10 chord theorem. So there's the tangent, there is your chord, right? Angle opposite that chord, right? Okay, so that means that that angle is equal to x. So therefore, now look at this. What happens? So S1 now becomes an exterior angle to that quad, which is SMRC. Okay, so because the exterior angle is equal to the opposite interior angle, therefore in this case it must be a cyclic quad. All right, so let's start. How do we write it down? So 10.2. Okay, what did we do? Remember, we had already concluded that S3 was equal to S4. In fact, we could have even used S4 as the exterior angle, right? So we said R1 and 2, or you can say angle ARP, right? So that's R1 and R2, angle ARP, right, would be equal to, so which it's actually made out of R1 plus 2, right? So R1 and R2 would be equal to angle Q1 plus Q2, equals to angle Q1 plus Q2, right? And why is that? We said because of the 10 chord theorem. All right. Another way you could have gotten those to be equal. Now remember, guys, that tangents from the same point are equal, isn't it? So so if you look at this, AP is equal to AR, right? So that makes that triangle ARP an isosceles triangle. And guess what? So if you look at that, that would be equal to x. Of course, that would be, that angle there would be equal to x. Again, 10 chord theorem, but that will also make this angle equal to x. All right, because in this case, again, it is the base angle of an isosceles triangle. I hope that you're getting the hang of this base angles of an isosceles triangle. Okay. Right, now the last one. Okay, did we actually write out the entire thing? Yeah. So R1 equals to Q1 plus Q2. We said 10 chord, right? And as a result, now R4 is equal to that R1 plus R2, which is equal to X. So R4 is equal to R1 plus R2, which is equal to X, right? And so therefore, SMRC is a cyclic quad, right? But now why is it a cyclic quad? Because of the converse. So we are applying the fact that, right, the exterior angle of that cyclic quad is equal to the opposite interior angle. Okay, so the converse in this case of a converse exterior angle of a cyclic quad. Okay, right, I hope that makes sense, guys. And please note, once you prove that something is a cyclic quad, it means that now we can actually use the fact that it is a cyclic quad to prove the next point, right? Okay, so now I want us to go back to that. Okay, they say RP, prove that RP. Okay, so RP is this line here that I'm going to show in yellow. Okay, right, so it's the yellow line. So there it is. They say prove that RP is a tangent to the circle passing through PS and A, right? So a circle passing through P, S, there's S over there, and A, right? I know my circle is not really a circle, right? So prove that PS is a tangent to that circle that's passing through PS and A at P, right? So there's our tangent there. Now remember, if it is a tangent, remember there's no circle over there, right? So if RP is a tangent, then what do we note? We have to have, in this case, the 10 chord theorem applicable, right? So notice if we have the tangent, the angle between the tangent and the chord, so that means in this case that would be P2, should be equal to, there's our chord, the angle of the opposite side of that chord, right? So that means that we must prove that P2 is equal to angle A2. Now, please, I want you to stay with me, ladies and gents. Right, I'm gonna again go back to the fact that we've got that x. All right, I want us to indicate those angles that are equal to x. Right, I know that it looks clumsy, but it helps at the end, right? So let's try and clear out our diagram. So we said which angles were equal to x. We said, right, that R2, R3, right? You remember we had angle, rather I meant S3 and S4, and then it was that R3, but it was that entire angle Q, right? And in this case, it made angle P as well, P1 and P2 rather, equal to X. Okay, so this made angle S1 also equal to X. Those are vertically opposite. It makes S6 equal to X, vertically opposite again, right? We've also found out that this was equal to X, right? We used the 10-chord theorem, okay? And which other angle was equal to X? All right, yeah, so I think that would be sufficient. Now, ladies and gents, what I'm going to do here is I am going to introduce another variable, right? So I'm going to say, let's let P2 be equal to Y. Please, I want you to listen very carefully. So now I need to prove that that angle A2 is also equal to Y, right? So I'm letting P2 be equal to Y, okay? So now I want you to note that makes P1, please listen carefully. So remember the whole of P1 and P2 was equal to X, and if P2 is equal to Y, then it means that P1 would be X minus Y. So this angle here would be equal to X minus Y, right? And then which other angle do I have, right? But that means that this angle also is equal to Y. These are angles at same segment. Okay, let's take that color again. So this would be equal to Y, right? So remember P2 is equal to that entire angle there, right? So that means that's angle Y. And so it means that Q2 would also be equal to Y minus X. All right. Now, ladies and gents, please, 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 I want you to stay with me and I want you to listen very carefully. Right. Now, if I'm going to make that angle Y, right? So, which means if I look into the triangle, now you can go into, let's see, which triangle can we go into? Okay, so if I go into triangle APQ. Now remember, what was this angle here? This would also be equal to X. Remember, that's the 10-chord theorem, isn't it? Okay, so if I look at, let's see. So I've got Y minus X. So if I look at that entire triangle, right? So look at this. I've got this guy equal to 180 minus 2x. All right. I don't want to complicate it, but please just follow me in what I'm doing, right? So I've got that angle there, which is 180 minus 2x. Right. Now, if we go into triangle PAQ, right? So which means I'm looking into this triangle here. Okay, so my lines tend to misbehave. Okay, so triangle PAQ, right? Now, what would be the size of angle Okay, I want to try and indicate it. What would be the size of this angle over here? Right? So you've got 180 minus 2x plus x. Right? So remember, this entire angle here is x. That is P1 and P2, right? So that makes that entire angle 180 minus 2x plus x, which makes it 180 minus x. And we've got angle Q2. Now, please note, P in triangle PAQ, right? What did we do? We said angle APQ. So APQ is equal to, remember, this would be 180 minus 2x plus x. Plus x. And so that gives us 180 minus x. Another way in which we could do that is that, remember, sum of angles on a straight line, right? This angle here is equal to x, so that makes this entire angle 180 minus x. In fact, that was the easiest way in which we could do that, right? So APQ is 180 minus x, and then angle Q2, we just found out that this is equal to, right, because we made Q1 y, right, because it was equal to P2, so that means that Q2 would be y minus x, right? Now, in that triangle, angle A2 plus angle APQ plus angle Q2 are equal to 180, right? So we're looking for angle A2. So what would be the size of angle A2? That would be equal to, and by the way, what would be the reason for that? These are sum of angles on a triangle. So that's angles in a triangle, right? So now A2, this is what we're looking for, plus APQ, we said that's 180 minus x. Q2, this is y minus x. Okay, and this is equal to 180. So now, sorry, this is not y minus x, rather x minus y. Sorry about that. So x minus y. The big angle is x. It subtract that small angle there. So this is y minus x. Rather x minus y. Why do I keep saying that? Okay, so now let's try and get the size of that angle. So I see minus x and x would cancel, right? And that means that A2 would be equal to, take the 180 to the other side, so 180 minus 180 plus y, and that cancels. So what makes angle A2? A2 would be equal to y. All right, and so it proves that this angle here, A2, is equal to y. And so definitely it means if this was a tangent, okay, that passes through PSA, then we would be able, okay, my circumference should pass through here, we would be able to apply the 10 chord theorem. Okay, right, I hope that made sense, ladies and gents. So let's do that again. So let's say we said for 10.3, let angle P, we said P2 equal to y. Let P2 equal to y. And so what did that do? Okay, so what it did was to make angle Q1 equal to y. So P2 is equal to Q1, which is equal to Y. These are angle at same segment. Okay? Angles at same segment. Now, then we said, then it means that Q2, remember, this would be the big angle, Q1 and Q2 was equal to X minus Q1. In this case, that means that Q2 would be equal to X minus Y. Okay? So therefore, Q2, okay, but we knew that Q1 plus Q2 is equal to X. Okay, so Q1 rather plus Q2, that was equal to X, right? We had proven that, well, we had said that before, but now we said Q1 is equal to Y, right? Plus Q2 equals to X, so therefore Q2 would be equal to X minus Y. All right, so we express that as X minus Y, right? So now, in triangle APQ, right? So we said the angle APQ rather would be equal to 180 minus X. Remember, we said this angle here is equal to X. So this entire angle would be equal to 180 minus X. That's angles on a straight line, right? So APQ right is equal to 180 minus let's say angle P4, right? And therefore it's 180 minus X. And why was that? These are angles on a straight line. Okay, so this APQ is equal to 180 minus X, right? So now we know now that angle P2 is equal to Y. Now let's go into triangle. Now note, we said therefore, in triangle APQ, right, we note that A2 plus angle APQ plus Q2. So that's A2 plus angle APQ plus Q2 is equal to 180. And why is that? These are angles in a straight line, right? So sum of angles in a straight line. So we're looking for angle A2, right? Okay, let me just keep it together here. So we said APQ is 180 minus X, right? And Q2, you remember we said it's X plus Y. So that's X minus Y rather, is equal to 180. And so what happened? We cancelled these two. So that means that, and what does it do also? So A2 is equal to 180. If we take this 180 to the other side, it becomes negative, right? If we take Y to the other side, it becomes positive. So that means that A2 is also equal to Y. So therefore, right, note, it means that P2 is equal to A2, which is equal to Y, right? So those two angles are equal. Therefore, we can conclude that RP is a tangent. Okay? So RP is a tangent, okay, to the circle, to circle PSA at P. And why is that, ladies and gents? Because we could use the converse of the 10 chord theorem. Okay, so the converse of the 10 chord theorem. Now, because they are equal, in this case, because P2 is equal to A2, so then it means that the 10 chord theorem is applicable in that case, and therefore it makes PR a tangent in that case. All right. And ladies and gents, that is how you'd go about these questions. All right. I know that it looked a little bit complicated, but that is how the cookie crumbles. All right. So Euclidean geometry, I hope that it's getting easier and easier the more you see these questions. All right. But I'll bring you guys some more, of course, with past exam question papers as well. But look out for it. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.